and magic. It had no place in rational and enlightened science. Volta saw the experiment completely differently to Galvani. He believed it revealed something totally new. For him, the legs weren't jumping as a result of the release of animal electricity from within them, but because of the artificial electricity from outside. The legs were merely the indicator. They were only twitching because of the electricity from the Hawksby machine. Back in Bologna, Galvani reacted furiously to Volta's ideas. He believed Volta had crossed a fundamental line from electrical experiment into God's realm, and that was tantamount to heresy.
To have a kind of spirit like electricity, to have that produced artificially, and to say that that spirit, that living force, that agency was the same as something produced by God, that God had put into a living human body or a frog's body, that seemed sacrilegious to them because it was eliminating this boundary between God's realm of the divine and the mundane realm of the material.
Spurred on by his religious indignation, Galvani announced a new series of experimental results which would prove that Volta was wrong. During one of his experiments, he hung his frogs on an iron wire and saw something totally unexpected. If he connected a copper wire to the wire the frog was hanging from, and then touched the other end of the copper to the nerve, it seemed to him that he could make the frog's leg twitch without any electricity at all.
Galvani came to the conclusion that it must have been something inside the frogs, even if dead, that continued for a while after death to produce some kind of electricity.
And the metal wires were somehow releasing that electricity. Over the next months, Galvani's experiments focused on isolating this animal electricity using combinations of frog and metal, Leyden jars and electrical machines. For Galvani, these experiments were proof that the electricity was originating within the frog itself. The frog's muscles were Leyden jars, storing up the electrical fluid and then releasing it in a burst. On the 30th of October 1786, he published his findings in a book, De Animali Electricitati, of animal electricity. Galvani was so confident of his ideas, he even sent a copy of his book to Volta. But Volta just couldn't stomach Galvani's idea of animal electricity. He thought the electricity just had to come from somewhere else. But where? In the 1790s, here at the University of Pavia, almost certainly in this lecture theatre, which still bears his name, Volta began his search for the new source of electricity. His suspicions focused on the metals that Galvani had used to make his frog's legs twitch. His curiosity had been piqued by an odd phenomenon that he'd come across: how combinations of metals tasted. He found that if he took two different metal coins and placed them on the tip of his tongue, and then placed a silver spoon on top of both, he got a kind of tingling sensation, rather like the tingling you'd get from the discharge of a Leyden jar. Volta concluded that he could taste electricity, and that it must be coming from the contact between the different metals in the coins and spoon. His theory flew in the face of Galvani's. The frog's leg twitched not because of its own animal electricity, but because it was reacting to the electricity from the metals. But the electricity his coins generated was incredibly weak. How could he make it stronger? Then an idea came to him as he revisited the scientific papers from the great British scientist Henry Cavendish, and in particular his famous work on the electric torpedo fish. He went back and took a closer look at the torpedo fish, and in particular the repeating pattern of chambers in its back. He wondered whether it was this repeating pattern that held the key to its powerful electric shock. Perhaps each chamber was like his coins and spoon, each generating a tiny amount of electricity. And perhaps the fish's powerful shock results from the pattern of chambers repeating over and over again. With growing confidence in his new ideas, Volta decided to fight back by building his own artificial version of the torpedo fish. So he copied the torpedo fish by repeating its pattern, but using metal. Here's what he did. He took a copper metal plate and then placed above it a piece of card soaked in dilute acid. Then above that, he took another metal and placed it on top. What he had here was exactly the same thing as Galvani's two wires. But now, Volta repeated the process. What he was doing here was building a pile of metal. In fact, his invention became known as the pile. But it's what it could do that was the really incredible revelation. Volta then tried his pile out on himself by getting two wires and attaching them to each end of the pile and bringing the other ends to touch his tongue. He could actually taste the electricity. This time it was more powerful than normal, and it was constant. He'd created the first battery.
The machine was no longer an electrical and mechanical machine. It was just a purely electrical machine. So he proved that a machine imitating the fish could work, that what he called the metal or contact electricity of different metals could work. And that he regarded as his final winning move in the controversy with Galvani.
What Volta's pile showed was that you could develop all the phenomena of animal electricity without any animals being present. So, from the voltaic point of view, it seemed as if Galvani was wrong. There's nothing special about the electricity in animals. It's electricity, and it can be completely mimicked by this artificial pile.
But the biggest surprise for Volta was that the electricity it generated was continuous. In fact, it poured